Alright, let's do a couple of quick calculations involving GPE and KE, just to get an idea of how it might be done. GPE, of course, being the gravitational potential energy, and KE being the kinetic energy. So, the good thing is that we have two simple little equations to use. For GPE, gravitational potential energy is equal to the mass times gravity times height, mgh. So the mass is measured in kilograms. Gravity on Earth is taken as 9.81 newtons per kilogram. And the height is, of course, measured in meters. Using these units, we'll come out with our unit for GPE in joules, which is good. That's what we want because it's energy. The units are, in fact, the joule. For kinetic energy, also measured in joules for energy, well, KE equals half mv squared. So again, m, the mass is in kilograms, v for velocity, that's in meters per second. So here are two fairly simple little equations that we're going to use. GPE equals mgh and KE equals half mv squared. Let's just do a couple of quick questions using each equation. So first up, a student whose mass blah 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 blah, what would the GPE be? Okay, so you'll note I didn't really read the question entirely, I just went straight to what am I actually needing to find. Okay, so I'm finding the GPE, so I don't need to rearrange my equation, mgh. And now I can go back to the question and get the other details. So the mass is 50, we know gravity on Earth is 9.81, and the height is 25, and we do this calculation, we come out at 12,262.5 joules of energy, no rounding, there we go. So that's just a very quick example of how we use the formula for calculating GPE, the gravitational potential energy. Let's do another one. Okay, next question, she decides to climb higher. Okay, there are two ways we can do this. One is to do essentially the same thing. Mass times gravity times height. The height is now 50 meters. The student first went to 25, now climbed 25 higher. So we'd have 50 times 9.81 times 50. We could do that, get our answer, fine. But there is another way. We can see here that GPE is directly proportional to height. Now the height has doubled because the height was originally 25 meters. She climbed another 25, so the height has doubled, and that means that the GPE is also going to double. So what we can do now is just take our answer from the previous question, what was it, 0.5, and we just times that by 2. And that gives us our new answer of 24,525 joules. I just think this is a quick way to do it. Once we realize that, oh wait, GPE, height, they are directly proportional. If I'm going to double the height, I'm going to double the gravitational potential energy. It's a bit of a quicker way, but if not, that's fine. You could still do your 50 times 9.81 times, well, it was 25 and then it's another 25. There we go. You can still do the calculation. You're going to come out with exactly the same answer. Okay, next question. Instead of a student, we're talking about a ball, half a kilogram mass, kicked straight up. How much GPE does it have at its highest point 6 meters off the ground? Okay, so once again, we're just using our straight formula. We're not needing to rearrange. There we go. And we put in our values. Well, the mass is half a kilogram. We know gravity is 9.81 and the height is 6 meters. We reach for our calculator and we find out it's 29.43 joules of energy that ball will have at the highest point, 6 meters off the ground. Now for our final example of using GPE for a calculation, we have the same ball, we have the same amount of GPE, so we're not finding that this time, but we're still going to start with that equation because that's what we do. We start with the equation and then we need to rearrange as we see fit. So in this case, we're looking for the height, so the height is equal to, what have we got, GPE over mg. And then, as always, we plug our numbers in. So the GPE, 29.43, that was calculated in the previous question. The mass is the same, also half a kilogram, and the gravity is less because we're on the moon and gravity is 1/6 of what it is on Earth. So we're not using 9.81. The question specifically told us, hey, here's the new gravity to use. So we're going to use it. And that gives us an answer of 36.8 meters high. This has actually been rounded to one decimal place. Anytime we round, we need to show our rounding. Now, let's move on to some kinetic energy calculations. Okay, to start with, we're back to a student. All right, well, let's go to our equation. KE, kinetic energy, is equal to half mv squared, which is equal to 0.5 times, and now we go back to the question. We look for our data. Well, the mass is 50 kilograms, and they're traveling at 5 meters per second, but remember it's 5 squared because it's v squared. Well, that's 25 times 25, and that is 625 joules. Maybe you could even do that one without your calculator, right? Because half of 50, that's what I did. Half of 50, that gives me 25, and I know 5 5s are 25, and then I just need to multiply 25 times 25. If you don't want to do it like that, that's fine. Do it however you want. Reach for your calculator. You'll get this answer. And let's move to another question. Here we have a roller coaster. What are we actually looking for? Determine the KE. Okay, so don't need to rearrange the equation. We're just going straight into it. Half mv squared. So 0.5, there's our half. Our mass is 625. Our velocity is 18.3, but remember that is squared. And now we reach for the calculator on this one, and that comes out at 104,653.125. So that's an eighth of a joule. So there we go. There's our answer. Now we can go a step further if we want. We could leave it like that, and that is perfectly fine. But it's a long answer. Let's just make it a bit of a shorter answer, and we'll call it kilojoules instead of talking about joules. So instead of 104,000, let's just make it 104 by changing our units from joules to kilojoules. Yeah, I'll also round. Let's just call it 0.65 kilojoules, and this has been rounded to 2 decimal places. Now, like I say, you could have stopped at 104,653.125 joules. That is the answer. But if you want, you can take it one step further. Change the unit by putting a prefix just to make it a smaller number, and I also rounded as well. So there we go, 104.65 kilojoules to 2 decimal places. Alrighty, Missy, blah, 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 blah. What was her speed? Okay, so we're looking for velocity. We're given kinetic energy, so we can jump straight into our kinetic energy equation. But then, of course, we have to rearrange this equation because we're not looking for the energy, we're looking for the velocity. So we rearrange this to say velocity is equal to square root of 2 times the kinetic energy over the mass, which is equal to the square root of 2 times 12,000 that the question gave us, and the mass is 40. And then we reach for our calculator and we come out at 29.5. It's velocity, so the units are meters per second. So there we go. Now, the whole rearranging stuff, I do actually have another video that I've made previously on how to rearrange equations, so I'll put a link to that in the description down below, so you can check that out if you need a refresher on the whole rearranging equations so that it finds what you're needing it to find. Like in this case, I had to rearrange so that it was finding the velocity. But link down below to that other video. And now we have one more question on kinetic energy. So here it is, final question. We're looking for the new kinetic energy. Okay, so we want KE. So kinetic energy is half mv squared. Now, there are actually 2 ways to go about doing this. We could, and in fact this is like earlier in the video, there were 2 ways to do a GPE problem, but remember the GPE was directly proportional to the height, so if the height doubled then the energy doubled, so we did it that way. We're going to do the same sort of thing with this one here. We could work it out. We could take, okay, well, half times the mass, yep, I've got the mass, times the velocity squared, well, yeah, I've got a velocity 50 kilometers per hour, and we could work out the kinetic energy. when the a car was going at that speed. We would need to do an extra little step because the speed is given in kilometers per hour, and this equation, remember, we use velocity in meters per second, but that's fine. We can take our 50 and divide it by 3.6, and that will give us the meters per second speed instead. So we could just do a straightforward calculation, but because the terminology of the question has this sort of estimate its new kinetic energy, that sort of tells us that, hey, maybe we don't need to do the full calculation. Okay, so much like that earlier example with the GPE, what we have here is a changing velocity, and it's dropped. So when velocity goes down, kinetic energy is going to go down as well. Kinetic energy is directly proportional to the velocity squared, right? So when the v squared goes down, ke goes down. Now, velocity is half, right? That is half. But that doesn't mean that kinetic energy is half. No, no, no. Velocity is half, but remember, it's velocity squared. So it's actually half times half, which comes out at a quarter. So the velocity squared, right, that number is going to be a quarter of the original value, which means the ke comes down by the same factor, so that's going to be a quarter of the original value there as well. So what we have now is 347,000 joules of energy, which is simply going to divide that by 4. We're going to take a quarter of it, and we're going to come out at 86,000. Well, that didn't work, did it? I don't know what's going on with my stylus at the moment. So what was I saying? 86,750 joules. So it's just a different way to do it. Like I say, you can actually go through the whole calculation and work it out precisely. That's fine. But this was, all I need to do was take this one number and divide it by 4. And that gives me the answer. So, sweet. Bit of a shortcut there. Anyway, that's going through a few quick examples of using GPE equals mgh and using ke equals half mv squared. So if ever you have problems involving these two equations and these two forms of energy, hopefully you'll be sorted.
Like the video, punch that like button. Want to see more videos? Smash that subscribe.